This is another example of second derivatives, of finding second derivatives, and it's a harder one than the previous one in the notes. So let's go through it in a step-by-step fashion. F of x, the original function, is equal to 3e to the 2x squared minus x. Okay, so we need to find the first derivative, f prime of x. Okay, so it's an e function. You're multiplying by f3. When you're multiplying a function by a constant, you keep the constant. So now we move on to the e. And remember, whenever you differentiate an e, you get exactly the same thing back again. So it's 2x squared minus x. So e to the 2x squared minus x. But remember, we have to multiply that by the derivative of 2x squared minus x. And the derivative of 2x squared minus x is 4x minus 1. So this will be 4x minus 1. Okay, so that's the first derivative at that point. Okay. Now, if we're going to find the second derivative, which is what we're asked to do next, we have to differentiate this function. And what we found in part A was you've got a piece of the function that has x's in it here, and another piece of the function that has x's in it here. Okay, so there are two pieces of this function that contain x. We're not adding or subtracting them, so it's a product rule question. Okay, this is now a product rule question. Okay, so we might as well do it this way. We didn't use it to find the first derivative, but we certainly have to use it to find the second derivative. So we'll say that u can be 3e to the 2x squared minus x. And let's say v is equal to 4x minus 1. Okay? Now, the handy bit about functions that have e's in them is 3e to the 2x squared minus x. Well, that is what we differentiated initially. Okay? Now we're just differentiating the same thing again. So we know the answer for this. The answer for it is what we got as our first derivative. So this will be 3e to the 2x squared minus x times 4x minus 1. Now if you want to, you can try working that out again. But you already have differentiated this. This was the original function, and it's now become the u of the first derivative. So we've already got that done. Now, the second part of this, v prime, is just going to be 4. Okay? So if we want to use the product rule, now, it's going to be f double prime of x. Remember how it goes. It's u by v prime, so 3e to the 2x squared minus x by 4 plus v by u prime, so plus 4x minus 1 times, I beg your pardon, 3e to the 2x squared minus x by 4x minus 1. I realize that I left out the parentheses there, so let me go back and address that. Okay. Now, I guess you can look to see, is there anything that you can factor out of here, and it's almost always going to be the exponential part of it. So it's going to be 3 times e to the 2x squared minus x is in both of these terms. Is the first term, there's the second term, and each term contains 3e to the 2x squared minus x. So we can remove that as a factor. Okay, so it's going to be 3e to the 2x squared minus x. If we take that out, then out of the first term we're just left with 4. And out of the second term we're left with, if we remove this, we're left with 4x minus 1 by 4x minus 1. So that's 4x minus 1 squared. Now if you want to, you can continue simplifying that. So that would be 3e to the 2x squared minus x times 4 plus, if we square this out, the first one squared, 16x squared, minus 2 times the first by the second, so minus 8x, plus the second one squared. So it'll be 3e to the 2x squared minus x times 16x squared minus, I forgot the one there, minus 8x plus 5. Double prime of x. Okay, and that would be the second derivative. I guess you could say that on the very first line, this line here, that's an equally valid statement of the second derivative. It looks a little bit neater here. Okay, so you can write it there. Okay, so a lot more work than the last time, and you have to be careful. You have to spot the product rule when it comes into play. Okay, but there's the entire problem. Okay, thank you.